All right, so we have this idea of particle separation. I know if I have a bunch of positive charges here and a bunch of negative charges there, I'm sort of flashing back to chapter 45 or 6, that if I measured a voltage, I can tell which is the high side and the low side. You did this in the equipotential line electric field lab where you had the probes on one, then you switched the probes or switched the leads, and you got a negative of what you had before. So you can tell which is the high side, which is the low side. If I have a bunch of positive charges on one side, negative charges on the other. So now, if I take a wire and I run a current through it, let's make the current flow this way. This is a wire. What physicists did not know early on was, is the current flowing this way because of protons flowing, or is the current going this way because of electrons going the other direction? There's really, up until Hall comes along, no way of telling what was actually causing the current flow. So now we have a technique. If I expose this to a magnetic field, and again, magnetic field's coming out at us because dots are easier than crosses to draw. If this is because I have protons or some positive charge flowing in that direction, so I have protons moving this way, magnetic field coming out, in which direction will the protons be moved?
So which way is the proton coming in?
The proton. If I have a current going this way, it's either because I have we'll just say protons going this way or electrons going the other way. So the question I'm posing is, if I expose this to a magnetic field, if there are protons flowing, which way would the protons be moved?
To the left.
To the right of the wire.
Say it again. Sorry.
All right, so I have a wire, current flowing this way. I do not know at this point, as historically speaking, whether this current is caused by positive charges flowing this way or negative charges flowing the opposite direction.
But the current is going.
Yeah, we do know the current's flowing that way. I can set up a battery, I know the high side and low side of a battery, I can connect it to a wire, I know which way the current flows.
My money's on the left.
My money is on.
All right, so we'll first do the V cross B. If it's a positive charge, that means it's flowing that way. V is up, B is out. So up, out, protons will be forced to the right.
Yeah.
Oh, I forgot to give you time to make a bet.
Could have won easy money.
Next time. So if these are protons flowing, protons would be moving, or some positive charge, they'll be moving off to the right. If it is a negative charge flowing, negative charge is flowing this way, so V is down, B is out, the thumb points to the right, except the charge is negative, so that flips it. The electrons, so if it's electrons flowing or some negative charge flowing, that would also be forced to the right. It's left, our right. So in one situation, I'm going to have a bunch of positive charges over here. In the other situation, I'm going to have a bunch of negative charges over here. So now I can take a voltmeter, in theory, attach it to both sides of it, and I can figure out which is the high side, which is the low side. If this is the high side, then it's electrons flowing. If this is the high side, it's the protons. Just notice the Hall effect. Edwin Hall. Keep wanting to say George Hall, but he's a doctor I had years ago. So the Hall effect of being able to do this, I can't, physically in terms of doing this, if I run a current through the wires we have upstairs, I'm not going to notice the big difference there. There are sort of specialized wires, conducting materials, I should say.
Is this true for every wire, where it is always protons flowing upwards, or is it flowing in the direction of current, or is it?
All right, so Ben Franklin had no idea what caused current. He pictured current as a fluid flowing through the wire. And so he did a lot of analogies with water current with electrical current. So he established this idea that water flows downhill. So let's assume that if I have a high potential and a low potential side, current's gonna flow from high to low. That would have been mid-1700s. I think he did his science stuff before when we were still a British colony. Then, as we got into more and more developing, somebody at some point realized, oh, okay, we've established, Ben Franklin set up the standard for which way current flows, but we don't know what's actually causing that current flow. So, we don't know if in a wire it's positive or negative charges moving. So Edwin Hall, 1879, comes up with this Hall effect of which will differentiate. So, answering your question, probably longer than it needed to be. In a typical wire, if I hook it up, I use the Hall effect, I apply a magnetic field, I get the right equipment, we determine that it's the negative charges that are flowing. Now, 99.9% of the time in your experiences, it's always going to be the negative charge flow. In physics though, we pretend, we're not engineers. I'm not worried about practical at the moment. I'm worried about, theoretically, if I have a charge flowing, what's happening. So if I have a proton flowing into the field, which I had drawn here somewhere, I guess I erased it. Oh, here. If I have a positive charge, I can have a positive charge flowing in here, or I can treat this like it's a current. So if I shoot a proton towards the door, yes, I can think of it as I got a positive charge moving that way, or I can think of it as I got a current flowing that way. If I shoot an electron towards the door, I would treat it as an electron going that way or the current going that way. Did I answer your question?
Yes.
And then some?
I believe so, yes.
Okay. And I think on that note, I have 2 minutes longer if Verizon is telling me the truth.
So, who's we want to see area? 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so just area. So, Nick, you're taking tests in the testing center Monday, and Fabian, you need to know when you're going to take the test.
Questions on that?
I think